everybody, this is our lesson on dichotomous keys, phylogenetic trees, and cladograms. So first let's start with dichotomous keys, and this is literally just a list of questions that you answer to help you identify an organism. So we're going to show you an example on the next slide, but using like coins. So we've got a bunch of different coins here, as you can see, and we have to answer questions that tell us what order that we go in. How do we figure out which one is the answer to the question, okay? So first we look, is the color silver? Well, if the color is silver to the coin that you would have, or to the example that you have, you would go on to question 2. But if you say no and the color is bronze, then you would go on to question 3. So if it's bronze, you skip number 2. You just kind of mark it out. If it is silver, you have to go through number 2 first. So then for number 2, let's say it was silver. If the diameter is more than 2.2 centimeters, then you're looking at a quarter and you're done. But if it's less than 2.2 centimeters, you have to then go on to question 4. So let's say it was less than 2.2 centimeters, so it was not a quarter. We're going to move on to question 4. Then you have to see if Monticello is on the back. If so, that's a nickel. If the torch or flame is on the back, torch and flame is on the back, then that is the dime. Okay, so just kind of look at those there. You really just have to answer questions yes or no, basically. And then that will give you and lead you in the correct direction. And you will do some examples of this today. Next, we have what are called cladograms or phylogenetic trees. We're going to go over both of those. So a cladogram is a diagram to show you the ancestry of a species. And then a phylogeny is the evolutionary history of a species, which we can show in a tree. So first, this is a cladogram, and you have these breaks where you have like questions you're asking, again, yes or no. If you meet the next requirement, you continue up the cladogram, up the ladder. If you don't, you branch off before that that question, okay? So any organism above the red line has the characteristics of that red line. If it doesn't, it breaks off before that. So, for instance, vertebrae is our first red line. Everything above this is considered or does have a vertebrae, okay? Next, it's bony skeleton. Well, sharks' skeletal systems are made of cartilage, which is not bone, so they are broken off before the bony skeleton rung. Okay, so that's why they're below that rung. Everything above that does have a bony skeleton. Then the next one is 4 limbs. Well, we have a ray-finned fish. We know fish don't have 4 limbs, so it's going to break off between those two. It does have a bony skeleton, but does not have 4 limbs. So then has an amniotic egg. Frogs do not have amniotic eggs, or amphibians in general, so you're going to break off there. And then from there, you go to eggs with shells. Primates and rabbits and rodents do not lay eggs with shells, so they're going to branch off. And then you actually have another branch here with hair. Both of these have hair, so they still continue past that rung. And then we've got crocodiles and birds up here. Keep in mind where these branches come off of this cladogram, so where we exit out between red rungs, is called a node. So it's where your lines meet the original question line. And then the next one, this is called a phylogenetic tree. And it's very similar to a cladogram. It's just drawn out a little bit differently. And it might be a little bit more detailed depending on how many species you're looking at. So if we say that we're looking at the Protist kingdom, okay, from there, we can go on and ask these questions. Again, at each little space between lines is where we're going to have a question that we answer. So true tissue, this Portifera does not have true tissue, so it's going to branch off before that statement. After that, we have bilateral symmetry. So this one right here that I can't read, I can't tell if that's an N there. The Daria here,